Rounded out by some
Jackie, and I will be your conference operator today. At this time, I would like to welcome everyone to the Infrastructure Management Community Webcast introducing CA VNA. All lines have been placed on mute to prevent any background noise. After the speaker's remarks, there will be a question and answer session. If you would like to ask a question during this time, simply press star, then the number 1 on your telephone keypad. If you would like to withdraw your question, press the pound key. Thank you. I would now like to turn the conference over to Jeremy Rosbach, Senior Principal Product Marketing. Please go ahead.
Thank you, Jackie, very much. Good morning, good evening, good afternoon, guys, where you are around the world. Very happy to be on the line today, especially with my counterpart, Brian Jackson. We are happy and excited to introduce a new product from CA, developed in-house by CA, called CA Virtual Network Assurance. And it is an amazing product that we're happy to develop to really help you guys, our current CA customers, on your acceleration and successful deployments of the new next generation network technology we all know of as software-defined networking and network functions virtualization. So let's talk about why we developed the product, why we feel it needs to be a strategic part of your infrastructure management strategy when you look to deploy this technology. I'll get through some of these marketing slides, but it really gives us the understanding of what businesses and you as CA customers are dealing with today when it comes to demands, specifically demands on your network, right? We all know the numbers. Most of the internet will be made up of video in just a few short years. The traditional IoT jargon we hear about, 26 billion, 30 billion devices being connected to the internet in a few short years. All these are fighting for bandwidth on today's networks today, even your networks today. Thankfully, SDN and NFV are around, and just like server virtualization years ago, the adoption rate is continuing to go up as folks watch other innovators maybe like AT&T and Telefonica or even CenturyLink lead the way to their successful adoption and deployment of this next generation network technology, SDN and NFV. So we know there's a need. We know there's challenges from the digital consumer, wanting more and more bandwidth. We all want more and more bandwidth, even as end users in our home wireless networks. And the leading innovators are leading the way in this transformation to new next generation network technology. So it's happening. It is happening, and we're happy to support that transformation. And we are at the beginning of a revolution today for today's networks. We want to make sure our customers are ready. SDN and NFV will fuel and transform the application economy to meet those network demands and digital consumer demands like we just saw. But, hey, let's put the brakes on here. There are a few concerns we need to deal with, right? SDN and NFV comes with it a complexity in networking that has never been seen before. The scale and scope of changes, the vendor landscape and technologies, the vast ways of communication protocols and APIs and non-SNMP communications, they all bring with it challenges that network operations teams have to make sure they're ready for. What about the fact that we need visibility into this technology and how the underlay and the overlay, the physical and the network, the physical and the virtual networks talk to each other, relate to each other, depend on each other? What about the idea of so many things happening so quickly in this new technology and landscape? How do we automate responses to dynamic changes? For example, an interface on a virtual firewall is exceeding 80% of its allocated bandwidth. How do we automate a response to that, adding more bandwidth, not just notifying someone? This new technology can't wait for a manual response. What about automating, additional bandwidth to be allocated automatically and enabling self-healing or self-optimizing networks? How do we begin to troubleshoot this very complex and highly dynamic SDN NFV ecosystem when there's so many things happening so quickly, so fast. And like we mentioned, there's so many vendors and their flavors of orchestrators and controllers and hypervisors popping up on the landscape today. Nobody wants to log into a dozen different consoles to manage their SDN environments. So that's the challenges with the technology. What about the challenges with infrastructure management today? There are many gaps. Most of the folks on the line today are existing CA customers. They understand that CA infrastructure management solutions have a long reputation for doing wonderful work in the physical network space when it comes to performance and fault management and isolation. But, can that scale to what SDN and NFV demands from service assurance solutions today? There are gaps. There are gaps, right? SDN and NFV can't wait for a physical router to be ordered and hit the loading dock and racked and stacked. We can't continue to over-provision bandwidth as an insurance policy, just throwing more bandwidth in hopes that we won't run out and create bottlenecks. And there's no way for us to continue 5-10-minute hourly polls for changes like we do today in an SNMP environment on a physical network landscape. Thousands of the virtual devices in SDN and NFV ecosystems can be spun up with a click of a mouse. How do you poll for something like that with traditional infrastructure management today? The answer is you can't keep up. You can't keep up. And, a recent survey that just came out yesterday from Enterprise Management Associates, maybe some folks were on this briefing, this webcast. Most service providers and large enterprises agree there are gaps. A third or less than a third of service providers surveyed agree that they think their existing infrastructure management tools can support SDN and NFV. That's less than a third that think they're ready. I wonder if those numbers are 100% true, but less than a third feel that they have what they need for SDN and NFV when it comes to network management, all the tools. And the enterprise answered exactly the same way. Only about a third felt they were ready to manage the network management complexity of SDN and NFV. Again, I think these numbers are lower. But what does that say? 2/3 or more of the industry out there know there are gaps in their infrastructure management strategy for SDN and NFV, and that's what we're talking about today. We talked about the very highly complex and dynamic stack of SDN and NFV. For most of our users out there today on this webcast, we visualize this SDN and NFV stack to look like your traditional layer 7 stack. But it goes way beyond that, folks, as you can imagine. What would this stack look like in a large CSP environment where every layer has thousands, if not tens of thousands of devices, especially inside of the service chain layer, where thousands of virtual firewalls talking and connected to load balancers, caches, WAN optimizers, et cetera, all supported by virtual switches, VMs, multiple flavors of hypervisors, and then the physical hosts underneath. How do you begin to unravel and peel back this very complex onion, which is the SDN NFV stack? As we talked about, traditional infrastructure management has limited visibility into the physical and virtual network relationships in this stack. No way to trace performance issues when there's so many devices spun up so quickly, connected to so many other devices. What are the dependencies and relationships in this new landscape? Multiple layers breeds complexity. Complexity breeds bottlenecks. It's just how it is. The more things we have in our network stack talking to each other, spun up, spun down, the more complex the environment becomes. All of this creates big difficulties in pinpointing bottlenecks, outages, overutilized, underutilized investments, and of course affects our mean time to repair, increases it. If we go into the stack a little bit more and start dissecting it, because it is a very important piece to the SDN puzzle, being able to dissect this new network stack and understand relationships, dependencies. How is the stack performing? What is the health of every device on every layer of the stack? Where do we find weak spots, bottlenecks, potential bottlenecks? How do we stay on top of it and monitor it? Even self-heal it down the road as the technology matures. And then rebuild the stack back up. What does it look like? What's talking to what? What's dependent on what device? How is the service chain supported? The always important revenue-generating service chain, which will be services, especially CSPs and large enterprises will be deploying, where customers can come in and spin up their own websites with firewalls in front of them connected to load balancers and have web caches to handle traffic. These will be consumable devices outside of the data center now. How do we manage all of this, the health of it, the stack performance of it all, and basically relate it to the end user experience? Well, this is our answer to it. It's CA's solution to the SDN NFV assurance challenges that we just talked about. CA Virtual Network Assurance in the middle here, very proud to announce, is GA at the end of December of 2015, and it is a flexible and scalable software gateway that extends the existing functionality of CA infrastructure management today. So specifically, CA performance management customers, CA Spectrum customers know the power of those solutions, especially what they can do in the physical network landscape. Virtual network assurance enables them to scale what they do today so well into the new SDN NFV landscape and its very complex network stack. So performance management and Spectrum subscribes to what virtual network assurance is collecting and analyzing inside the SDN NFV stack and network landscape, feeds that information back into those two systems to do what they do best, assure the health, the performance, map the topology, isolate faults, now doing it in the SDN NFV landscape. Again, this is a 1.0 product, and our roadmap is very exciting. We hope to extend the functionality of what VNA can do and allow other subscribers that are infrastructure management to subscribe to what VNA is delivering from SDN NFV to products like CA Unified Infrastructure Management, APM down the road, and more and more. That's the vision, but today, 1.0 out of the box, we are happy to have subscribers of VNA be CA Performance Management and CA Spectrum. And Brian Jackson on the call here will show you exactly how the products enable and assure the health and performance of your new SDN NFV environments. So we go from operational challenges to operational confidence. And again, Brian is going to dive deeper into how we do this, how virtual network assurance enables infrastructure management to fill those gaps and, you know, extend that visibility to understand the underlay and the overlay relationships and dependencies, identify and quickly deliver information about potential bottlenecks or breaches of thresholds on CPU, memory, disk, network bandwidth, especially in the service chain layer. Get that information to where it needs to be, get it resolved, and allow our network operations teams to focus more on the user experience and business initiatives that the business expects SDN to be successful on, and let us worry about this technology complexity that comes with SDN and NFV. We remove the complexity by dissecting all the layers, pinpointing dependencies and relationships, and eventually the bottlenecks that could occur between them in all the layers of the stack, allowing you improved performance and faster mean time for repair. You know, and we've definitely visualized how complex the SDN NFV stack can be. If you're going to walk away with something else today, it's how we're very proud to help visualize that service chain layer within the stack. These service chains within software-defined networking and network functions virtualization are very important revenue-generating services businesses will be delivering, that are delivering today as we speak. What makes up the service chain? What's the supportive infrastructure underneath of it? What are the building blocks? If any one of these ESX hosts or virtual switches have a bottleneck, the ESX physical CPU is close to full consumption. What are the relationships that are dependent on it? What's going to be affected? As we can see here, we visualize this for you. It dynamically changes as new components are added or deleted, and breaches are alerted and realized for definitely extending that visibility in this complex environment while ensuring the customer experience is where it needs to be. Always relating it back to the end user experience. And I believe this is probably one of my last slides before we get into the product demo. But as most of you know, if not all of you know, CA is not a hardware company. We're proud to be a software company supporting as many vendor flavors of technology out there today. Of course, with our 1.0 version, we try to identify the most prevalent and widely used open source and vendor flavors of hypervisors, cloud orchestration systems out there. And we're happy to work with our customers to extend the roadmap and visibility of more vendor SDN NFV technology as it pops up on the landscape today. All right. So Brian, I'm going to give you the ball here if you're ready to show exactly what the product can do from what I talked about.
Yeah, absolutely.
And folks, I do see some questions. If they haven't been answered already, we'll definitely, I'm sure we'll have time to get those answered. So keep them coming in.
And Jeremy, if you could let me know if you can hear me okay and see my desktop all right?
You sound and look great, Brian.
Great, thanks very much. Thank you everyone for taking time out of your day today to talk about our VNA product. It's a very, very exciting time to be in the network space, and I think we have a very compelling product here for you, as Jeremy's talked about. One of the things that I wanted to reiterate and talk about a little bit is that the VNA product actually extends the functionality of Spectrum and performance management, and in the future, other infrastructure management products or APM or other tools that we have in our portfolio. And as such, the product only has a configuration GUI. So basically, we configure it to talk to your SDN NFV environment, and then it pushes inventory and performance data out to the products that are subscribed to it. So you don't have to create all new groups, you don't have to create all new users, you don't have to worry about tying it into your Active Directory or any of that typical administrative overhead. It is simply a gateway that talks on one side to the SDN NFV environment, and on the other side pushes out updates as it receives them out to the other products. One of the things that the product does is it will use a concept of a plug-in for a particular technology. So for example, OpenStack, we'll have a plug-in for the Juno and the Kilo releases of OpenStack. And that plug-in is configured to talk to the controllers or orchestrators, et cetera, as required, and will then push that information into a normalization engine where we will figure out what the devices are, and we'll figure out what the relationship between those devices are. So if we see a change inside the environment, we then push that immediately out to all of our subscribing products. So the plugins, which we're developing for each individual technology, because typically they're different APIs, even between versions of OpenStack, for example, from Juno to Kilo, there are significant changes in the API. So you'll have a plugin that's dedicated to the technology that you're deployed inside your SDN NFV environment. And the nice thing about the architecture is that the application server, the NVA server, or the VNA server itself might be released, and this is hypothetically every quarter. But these plugins can be released out of band. So similar to the way performance management now has out-of-the-band device certifications, the VNA product has out-of-band plugins or certifications against technologies that can be deployed. So the engineering team is rapidly attacking each of these technologies because, you know, the SDN environment is very volatile. There are a lot of new players. There are a lot of established names. There's a lot of consolidation going on in the landscape. So we've taken this plug-in approach to be able to be as nimble as possible when looking at these products. And as always, we're looking for your input onto what you've decided on in your SDN NFV infrastructure. So that helps us release these plugins. Okay, so without further ado, I'm going to talk about Spectrum first. So Spectrum, for those of you who might not be aware of it, is our event correlation, fault isolation, root cause analysis tool. It does this with a process that we have called inductive modeling. And what that simply means is when we look at a device, we try and get as much information about the device as possible. So if I was looking at a physical switch router, I would go in and say, are you a switch? Do you have routing code running? Are you doing MPLS? Are you doing quality of service? Do you have VLANs, et cetera, et cetera, et cetera? And I build up this model of the device inside the database, and then I go through and say, okay, let's look at all of your interfaces and see what's connected to you upstream and downstream. And this allows us to produce a topology, and that drives our fault isolation and root cause analysis. So if you're familiar with Spectrum, as these newer technologies come out in the networking world, we typically have what we call a manager. So for example, we'd have an MPLS manager, we would have a VPLS manager, VPN manager, and it's probably no surprise to you that now we have an SDN manager. So the SDN manager is responsible for communication with the VNA system. So it tells the VNA system, hey, I want to subscribe to your updates for inventory. The VNA system then says, okay, here is your initial inventory of devices and their relationships. And then subsequently, when there's a change inside the SDN NFV environment, it pushes that onto Spectrum as well. So if we take a little deeper view into the SDN manager, I can see that I have two different types of models in here. The first one is a compute node. So this is the physical system that has virtual machines, virtual switches, NFVs running on it. And I can see I have compute node 1, 2, 3, 4 here. The second thing I have here are networks. So this comes from OpenStack. These are the neutron networks that we've discovered through VNA. And we can see underneath those that I have the subnet. Okay? And if I open up one of the compute nodes, I can then see all of the virtual machines that are being housed on that compute node as well as the virtual switches. Okay. Now, what's great about Spectrum and what we talked about, the inductive modeling technology, and what's great about VNA is the fact that it understands relationship. It does that normalization across vendors and across technologies in the SDN NFV environment, is that if I look at this compute node and look at a topology, I can see the relationship here between the compute node, which is this blue model up on the left-hand side. I can see the virtual switch, which is modeled, which is running on that compute node. And then I can see virtual machines that are running on that system and that they're connected to this virtual switch. I can also see NFV functionality down here. So I see a virtual firewall that's running here. And what this view does for us is, one, it gives us an idea of what's running on that system, and two, it's the connectivity, right? And this connectivity, again, is what drives our fault isolation and root cause analysis. So I'm able to bridge the gap here between the physical to the virtual. Okay. One of the things that we've done inside Spectrum, we had 3 use cases really for Spectrum that we wanted to hit for the 1.0 release of the product. The first one was a topology for the virtual overlay. The second one was the ability to map the overlay to the underlay. We'll take a look at that in a second. And then third, to the bread and butter of Spectrum, fault isolation. So let's take a look here. What we've added is a spotlight view. So if you're familiar with Spotlight, it takes different technologies and allows you to view them in the context of the topology connectivity. And you'll see here that we have service function chain as a new option for Spotlight. So I'm going to go ahead and select that. And you'll see that we've grayed out or dimmed this topology. I'm going to go ahead and select a service function chain here. Let's see if I selected the right one. There it is. And I can see now that we've highlighted or brought to the forefront a bunch of nodes in here. So I want you to see what's involved in this. So I see the compute node that the service function chain is running on. I can see the virtual switch or switches, as the case may be, that this service function chain is running. And then I can see the actual VNFs that are running. And you can see that there's a little number here in brackets, a number 1 and a number 2. And what those designate is the flow of traffic through the service chain. So as a user, if I go through this particular service chain, I'm going to go through this virtual firewall first, then a virtual load balancer, and then finally at the bottom there is a virtual cache as well. I'm going to get a little more information on this. I see the blue eye here, which in Spectrum denotes the ability to get more information about something. So I'm going to go ahead and click on that. And I'm going to extend this. And you're going to see that now we have 2 different views or tabs that are available for us for service function chains. So the first one I'm going to look at is this SDN service view. So if I go ahead and click this, I'm going to see the VNFs that are participating in this service chain. I'm also going to see now the direction that the traffic flows in. So just like we had the numbers down here, 1, 2 to denote 1, 2, 3 to denote the way the traffic was flowing, I can see from left to right the way that the traffic is flowing. So I'm going through a firewall, to a load balancer, to a cache here. And the intent of this view is simply what it's called, service view. I just want to see what the service entails. I don't need to know what's supporting it. I just want to see from a very high level what the service is and whether it's being impacted by something. Are any of these devices in a degraded state or in a fault state that might be causing issues for my users? The second tab I have here is called the SDN Virtual Overlay. And if I click on this, this is when I start to get a little more interesting view. So if I take a look at this, I am now looking at the underlay and the overlay together in a single view for the service chain. So I'm able to say, okay, so I know I go through the firewall first because it's denoted by this 1 in brackets. Then I'm going to this load balancer, which is number 2 in brackets. And then finally, this cache, which is number 3 in brackets. But I can see that these 2 VNFs in the first part of the service chain are housed on this particular compute node going through this particular virtual switch. And I can see that the third part of this service chain is on a completely different compute node and a completely different virtual switch. So this view gives us the ability to, again, tie the virtual and the physical together and see if there's a problem with the service chain, where is it degraded or in fault condition, and how can I address it best. So just like every other Spectrum model, these have the ability to be put into global collections. You'll get specific alarms for them. You'll get specific events for them. So you have the ability to manipulate them just like you would any other Spectrum model. And that's kind of the beauty of the entire architecture here. Again, it's extending your existing investment in these products with more information. It's a new way of polling it. It's a new high-speed way of polling that the traditional SNMP engines just couldn't either get the information or keep up with. So again, your workflow remains the same. Your ability to create groups and collections and things like that remains the same as if it was any other device inside of Spectrum. Okay, so that's 1.0 Spectrum integration with VNA. Now we're going to move on to performance management. So if you give me a second here, I'll just move over to another system here. So, oh, and I should mention as well that when we developed the VNA product, that product team develops both the server component and the client component for anything that is connecting to it. So what that means is when you upgrade to Spectrum 10.1 and when you upgrade to PM 2.7, 2.6, you will have everything that you need to connect to VNA. There's no additional installs. You simply point to the VNA server and say, hey, I want to subscribe to get updates. So it's a great way of not having to keep track of separate downloads and things like that. So performance management, for people that might not be aware, is our performance over time system. It uses a big data database on the back end that allows you to do baselining and thresholds and projections and things like that for metrics. And just like any other item that we're pulling from performance management, either SNMP or non-SNMP through CAM or SDN NFV through the VNA system, we create metrics, and you can again, baseline those metrics. You can create thresholds against those metrics. You can do projections against those metrics. You can create dashboards with those metrics, mix them in with other data sources dashboards. So we're keeping the same workflow. We're keeping the same ability to manipulate the data as you see fit. Again, your initial investment is safe in PM. You don't have to learn about anything else or create other groups or users or anything like that. So what we've done inside PM is kind of a kickstart dashboard system for you. So you can see here that I have an SDN NFV reporting section, and I have 5 different dashboards that we provide out of the box. Again, you can create your own dashboards using these metrics, but we figured that these 5 areas are areas that when we've talked to our customers during our development process, they kept bringing up these things. Hey, we need visibility into X, Y, and Z. So we think we've done that, kind of the 80-20 rule. Hopefully it has enough information out of the box that you can get going immediately. So the first one is our virtual inventory overview. And it's just what it sounds like. It is what VNFs are being provisioned or deprovisioned over time. So inside PM, you have the ability to change your time frame here, you know, the last hour, the last day, 7 days, custom time frames. And you can see what's going on by VNF type and by compute node. So for example, compute node 4, you know, over this time period had this many caches active at a time. And you can also see that in a graphical representation here in the top left. And this is a great view. You know, one of the great things about SDN NFV is the speed of provisioning. You know, you'll be able to have, Jeremy was saying, you know, you click on it and you spin up whatever you need. Well, that's good programmatically, being able to achieve the speed of business. But if there's an error or a misclick or a typo, you have a bad situation very quickly as well. So this gives you the ability to say, geez, why did we just spin up 5,000 firewall VNFs? You know, we're paying our vendors per VNF for these, and really what we wanted was 5 firewalls. Someone hit a typo, or there was an error in our provisioning process here. So that's the type of situation that we're trying to monitor with this type of dashboard. The inverse is true as well. Why did we just lose 300 firewalls? We're a CSP, and our customers are all doing a virtual firewall service with us. What's going on here? So we do that here in this graph. We look at the, let me log in here. We look at the type of VNF, and we give you a trend of those as well. We do the same thing for service chain instances, virtual network instances as well. And again, this is the kind of graph where you're looking peaks and valleys, right? What situation would occur, to cause a peak or a valley, a significant one in these types of graphs? And then we simply do one for each type of VNF as well. So that is the virtual inventory overview dashboard that we provide out of the box for you. The second one is virtual compute usage. And this is, full disclosure, this is not our GA product on the demo system. So you're going to see some weird memory settings here over 100%, and I apologize for that. In the GA product, that's been rectified. But this is showing CPU and memory usage of those virtual machines in the OpenStack environment, okay? And so this is your first view of VNA data that is typically done through SNMP, right? So if you have an agent on a server, you would go out and get the CPU and the memory. Well, this is all through the OpenStack API. We're leveraging Solometer data here. So this is all coming out of Solometer. So Solometer will provide you with CPU usage and memory usage and disk usage. That's what's populating these graphs. And you'll see overview of the infrastructure. You can hover over any of the individual systems and get their graphs. And then again, we go through virtual machine by virtual machine and graph that out for you as well. So again, this is classic CA, right? So for 18 years, we've been doing network management that's been cross-vendor, it's been cross-technology. We're a software company, we're the vendor and the hardware we're agnostic to. This is just simply another way of getting data, and depending on what cloud orchestration vendor you might be using, we would normalize that data and then present it up here so you would be able to leverage this dashboard across vendors. I'm going to look at the virtual storage now. Again, this is happens to be looking at OpenStack. It's Solometer data. It's giving us information on disk, and it's giving it an overview, and again, by virtual machine. I'm going to show you the virtual switch performance as well. So one of the things when we've talked to our customers, one of the major bottlenecks is virtual switch. And when a virtual switch starts to go south, it can have catastrophic implications because of the number of systems that are attached to it, right? So what we've done in the 1.0 product is looked at basically throughput of the virtual switch and presented a dashboard for you representing that. So you'll see packet rate in, network bit rate in, et cetera. Again, these are things that you can trend, you can threshold on, you can send notifications out when you start to hit issues. You can run projections on it, say, geez, we need to provision more virtual switches, or we need to address this issue because we're starting to hit a bad threshold point. You'll see under the inventory item here, typically, you'll just have devices under here, but when we've subscribed to Virtual Network Assurance, we get a couple more items in here. We get service chains, and we get VNFs. VNFs is simply a list of VNFs that we have discovered through virtual network assurance and any information that that VNF has been able to provide back to us. The real interesting view, just like inside of Spectrum, is the service chain. So I'm going to go ahead and click on service chain. I'm going to pick one of these. I should note, these are the names that typical service chains get when they're provisioned, right? Because it's software-defined networking. They'll give you some sort of UUID that's incredibly long and you're not able to remember what it is. We provide a name alias to almost all of the elements inside the SDN NFV environment with performance management so that you could rename this something like, you know, customer X service chain Y or VPN users coming in through the enterprise or things like that. So throughout this demo, you might see some of these long UUID type numbers, but rest assured you can change that to be something that's more human consumable. You'll see here, actually, the name alias is available. We just haven't changed it on this particular service chain. So this service chain, so this is the first real visualization that's come inside of performance management. We hope that you like it. There are other visualizations that are coming down the pike that I think that you'll enjoy as well. But this is showing us, again, with arrows, we're coming in from the physical into the virtual world and then back out. What we're also seeing at the bottom, though, these are the compute nodes at the bottom layer. These are the virtual switches. These are the virtual machines. And then finally, these are the VNFs themselves. So you can start to see, just like we did inside of Spectrum, underlay-overlay relationships, okay? And if I happen to click on one of these, so all of these are hotspots on the dashboard. So if I double-click this virtual machine, it's going to take me in context to the device page for that virtual machine. And again, I'm looking at ceilometer data here. So I'm able to see CPU, I'm able to see memory usage, etc., trends over time, all the typical information that I would see for a virtual machine. And if I go to the VNFs, I'll just show you that really quickly. Here, we're just showing you, again, all of the VNFs that have been discovered inside of the environment. And if we get additional information from the VNF vendor, when you click on this, we'll show it to you. These are very plain right now because this is simulated data, full disclosure. So there's nothing to show here. But if we had a plug-in for that particular VNF, we would extract more information, you know, usually proprietary type information for that VNF, and display it here for you. Okay, so Jeremy, that's really what I wanted to show today. I know we have, it looks like about 15 minutes here. Maybe we could start answering some questions.
Sure, Brian, why don't you give me the ball back? I just had a couple more slides to get through, and won't take long at all. All right. All right, guys, real quick, and once again, thanks for staying on. The attendance we have for this session is really great. Great to see a lot of folks joining today, and thank you again. You know, I wasn't going to include this slide, but yesterday we were speaking to a large service provider, and everything that they were hoping for from a software vendor for service-assured SDN NFV really matched perfectly with our 1.0 version and our vision. So as most folks on the line today probably understand, they are either thinking about or they are in the middle of deployments, but they're taking baby steps when they deploy SDN and NFV. And I don't mean that in a bad way. The technology is changing, and new vendors are popping up on the landscape every day. And just like where we were many, many years ago with server virtualization, folks are kicking the tires and are waiting to see what happens. But what they want is that they want, eventually, they want fully automated self-healing networks. And that's where we that's where our vision of virtual network assurance is going down the road as well. And we're happy to see that we're aligning the vision of the product to the vision of our customers. So a quick use case example is, like Brian mentioned, a service request might come in to provision a firewall or multiple firewalls. And that's gonna, that's gonna come through the orchestrator, and the provisioning gets done on the service chain layer, right? And this is where subscribers of virtual network assurance, today again, performance management and Spectrum come into play, and we get notified through virtual network assurance. Without it, we would not be able to discover and know that the virtual instances of SDN and NFV devices were out there. We start monitoring the environment, and we really start closing that loop. And then, of course, like we always do, we discover maybe a bottleneck or a threshold breach of 80% utilization of something. And we now notify the orchestration system in SDN that a bottleneck is about to occur. And down the road, this is where we see the vision of the product going. We already showed you how we can monitor SDN and NFV devices, understand where performance bottlenecks are, but injecting it back into the SDN ecosystem is where we want to take the product and where you want us to take the product, and that's what this use case is showing. We inject the performance data back into the orchestration system that does automated provisioning of more bandwidth, more CPU, more resources, whatever. And we now have self-healing, self-optimizing automated networks. CA adjusts its monitoring of the new bandwidth that's been allocated, and we continue the use case all over again, closing that loop. And we're happy and looking forward to working with advanced customers that have SDN NFV initiatives to help us advance the product. We're looking for customers to do a POC, a trial with us, to help us mature CA virtual network assurance while becoming early adopters of the solution. So please reach out to me. Please reach out to Tim Deep, our Virtual Network Assurance Director of Product Management. We are happy to talk to you guys about your roadmaps for the technology, where you would like to see the solution go, and help us advance it together. So real quick, and we do have time, so, hopefully this has already been seen, but some of the technical benefits about going from operational challenges to operational confidence. As you already saw, we're extending the visibility into the underlay and overlay relationships and dependencies, the physical associated with the virtual. You can see how we can easily provide help and identify bottlenecks in this highly dynamic, highly complex environment, and notify folks before those bottlenecks become outages. You can see that we are happy to, with this 1.0 version, happy to support as many vendors out of the gate as we can according to your roadmaps, and looking to work with you guys to support many more down the road. And then I showed you the vision, our vision and your vision of eventually self-healing, self-optimizing networks. And of course, technical benefits should translate into business benefits. The business expects SDN to deliver on automation and, instant fulfillment of services without customers having to wait. We can help reinvent service delivery for the business, not only accelerating deployments of services, but tailoring those services in near real time according to any bottlenecks or outages identified. We haven't even talked about DevOps, but how does the solution help complete the DevOps puzzle? Imagine deploying virtual networks for testing and development that are assured and managed and monitored appropriately. The network's not really talked about too much when it comes to DevOps, and this is helping complete the DevOps puzzle. What about, testing the new flavor of Cisco's router configuration and software on a test environment that is provisioned properly and managed appropriately, so we can be justified and assured that the new flavor of Cisco's router can go into production in a timely manner. Of course, we can help with over-provisioning of utilization and resources, and improving CapEx on top of what SDN and NFV is doing for capital and operational expenditures, and ensuring that your next generation networks meet business and exceed business expectations and their initiatives. So, and finally, before we get into any Q&A, join me next week on the 20th at 12 p.m. Eastern, when myself and IDC analyst firm, along with Brad Casemore, discuss the challenges, the opportunities of the SDN and NFV revolution. I will copy and paste this link. Let's see if this works. Copy and paste this link into a chat window. And you should be able to click on that. Mel or Brian, if you can click on that, or Guthrie, see if that works and takes you to a registration page. But you can register for that webcast as well. So why don't we look at any of the questions that came in. We do have a question. Brian, you can take this. Oh, it looks like you already got it.
Yeah, Jeremy, there seems to be maybe a little bit of confusion about how VNA actually gets the information. So let me review that a little bit. I probably went very quickly here to make sure we didn't run out of time. So the VNA system is an application server, and it has a series of plugins. The plugins reside on the VNA server themselves. So you are not installing agents on all of these VMs or VNFs or anything of that nature. And the plugin, as far as the administrator is concerned, has a configuration, and that configuration is based on what technology we happen to be looking at. So for example, if we're looking at an OpenStack cloud orchestration environment, we would require a few things like the IP address of a controller, a username, and a password onto that controller. We would need to know things like what the Ceilometer port number is in case that's been changed. But a lot of basic information. So if you're familiar with OpenStack and you've used like the Horizon dashboard or something like that, it's a lot of the same information. And that information simply allows us to then use the OpenStack APIs to query what we need to query for the information. And then the same would be true for NSX or OpenContrail or the Open Daylight controller or the OVSDB, for example. Each of those would be a separate plugin, and each of those would require some amount of information to be entered into its configuration so that we could successfully talk to that piece of infrastructure. So hopefully that clears it up a little bit.
Are there any other questions we haven't answered in the chat window or Q&A yet, Bri?
Yeah, Jeremy, and I'm not sure, I hate to throw a hot potato at you. Andy Nelson had a question regarding licensing and cost. I didn't know if that's something you could address or at least give a blanket statement on.
Yeah, I can take it as far as saying that we're pricing per VM, and we can have more detailed discussions on that if you'd like. So, and as you know, VMs can host tens, if not hundreds, of virtual instances on top of it. So licensing per virtual machine, and it can host as many virtual network devices that you want on top of that. So we can dive deeper if you'd like. Just get in touch with me. And how about anything else in the Q&A, Bri, that we haven't taken care of?
Yeah, so there's a couple here. So one of the questions is, are there other plugins already available in addition to OpenStack? And the answer is yes. So for the 1.0 release, we had OpenContrail, Open Daylight, Helium, NSX, OpenStack Juno, OpenStack Kilo. And we're already hard at work at some additional plugins as well. I don't have a time frame for those additional plugins, though I can tell you that especially at CA World, we heard a lot of really great feedback saying, hey, we do need to get Cisco APIC on the radar sooner rather than later. So I don't have a roadmap that I can share with you at this time, but that feedback is exactly the kind of thing that we need here. And Jeremy, do we have a new forum or community now that's been created around this product?
I can, if it's not created, it's going to be created very soon. We just went GA. Right now, I'm posting anything and everything in the infrastructure management community. And
okay.
You can follow me if you want, but we should see a product category in the CA community under infrastructure management soon if it isn't already there.
Okay, great. So that's the place that we need to go to start getting this feedback out to product management.
Excellent.
And let's see, we have a couple more minutes. Let me see if I can see here. There is no plugin for containers at this point. That's something that's under consideration as well. Can VNA trigger a rediscover? So VNA is the one that's responsible for maintaining the inventory of the SDN NFV environment. So it will keep a copy of the environment, and when there are changes to the environment, it understands what those changes are, and it pushes those changes out to Spectrum or PM or both if they're both subscribed. So what that means, Joe, is that Spectrum and PM are not doing discoveries in the traditional sense. So you don't have to create discovery profiles or anything like that. When you enable the integration or the subscription to VNA, it's responsible for doing all of that dynamically because it has to, because it's the volume and the speed at which it's happening wouldn't make it feasible for us to do, the traditional kinds of discoveries. So that inventory gets pushed out to PM and Spectrum dynamically, and the models in Spectrum's case will be created or destroyed, created or destroyed inside PM as well. Question is, so for me, VNA is a black box in the sense that you're not doing, like we talked about, discoveries or things like that. That's correct. You'll have to, anytime you introduce new technology into your SDN NFV environment, you'll have to you'll have to enter in the information for the plugin appropriately, and then you're done with it. So in a sense, yes, it's a black box for you. Target period for APIC support. We don't have a roadmap that I can share with you at this time, but go out into the communities and ask that same question, and hopefully our product manager, Tim Deep, will be able to answer that for you. We talked about the other plugins. Oh, so here's a great question too. So will Spectrum and Performance Manager correlate a VM if it's getting data from more than one source? So yes, it will do reconciliation. So use case is Performance Management has discovered a virtual machine via SNMP and is collecting information on it. VNA then also sees that from the cloud orchestrator and says, hey, here's a VM from the SDN NFV environment, and Performance Management or Spectrum will look at that device, match it up, and say, okay, I now have a richer set of data that I can present back to the users. So in addition to what I'm getting from VNA, I also have SNMP data, and it will be just one model in Spectrum or just one device inside of Performance Management.
Okay, we are at the top of the hour. I think we got to most of the questions, if not all of them. We do have a copy of the Q&A and obviously your emails, and Brian can hit the last couple if we missed any. Thank you guys again so much. I appreciate you sticking on till the top of the hour. Once again, we're very proud CA Virtual Network Assurance is GA. Look for a product category in the CA community very soon. You did take note of my email address if you have any questions. And once again, have a wonderful day. We will talk soon.
Thank you. This concludes today's conference call. You may now disconnect.